Welcome back to our second day of taking notes for Algebra 1-2. Our new section is going to be 1.2 Functions. That will be your title across the top of your page. The objective below is a statement that you should be able to make by the time your notes are complete. You should be able to say, I will be able to determine if a relation is a function, as well as find its domain and range. Some of the vocabulary and terms you're going to see today you have not seen before. That's okay, don't panic. We will be practicing these concepts from now through May. Once you have the objective written down, go ahead to the next slide. Here are only 2 questions for your warm-up. So underneath your objective, take a moment, write down these 2 questions, solve them, and when you are done, unpause the video and check to see how you did. Take a moment, compare your answers with mine, and let's see how we did. On number 1, did you start with the exponents? Because remember, these are not really parentheses because there is not a problem inside them to solve. 3 squared is our first exponent. 3 squared is 9. I simply rewrote everything else. I looked and saw multiplication would come next, so I've got 4 times 5 is 20. So we have 9 minus 20 times 7. Multiply again. 20 times 7 is 140. 9 minus 140 is a negative 131. If you made any mistakes, please take a moment, make the corrections now. Looking at number 2, did you look here? We actually have a problem inside parentheses. So this is where our focus begins. Inside the parentheses, I do have exponents. That is going to come before I add. 3 squared is 9. Then I rewrote the 2 plus 5, the parentheses, and the 9 plus 2. Next, I solved in the parentheses. 9 plus 2 is 11. Notice I stayed on this part of the problem until I got all the way down to only one number in the parentheses. Now I have a choice of adding or multiplying. Multiplying comes first, so 5 times 11 is 55, plus the 2 is 57. Please take a moment and make any corrections as you need, and continue on when you're ready. Did you have any questions over your basic order of operations homework from yesterday? Please take a moment. If you have not corrected your homework at this point, pause the video, correct the ones you were assigned, and if you have any questions, you're going to ask them in class. Proceed when you are ready. All right, here we go with domain and range. This is a very hard concept to grasp in the very beginning, but I guarantee you will be proficient as we move throughout the year. 2 key vocabulary words you're going to hear every unit from now through May are domain and range. Domain can be called the x values of all the points. They can be called inputs or independent variables. Because they are the x values, when we look at the graph, we look at the x-axis from left to right. The range is your y values. Those are also called your outputs or your dependent variables. When you're asked to give the range from a graph, you want to look from bottom to top. That is how the orders of the numbers increase on the y-line. They get bigger and bigger as you go up from bottom to top. Take a moment to copy those definitions and examples down. So the question is, what is a function? So if I give you a relation, it can be a set of points or it can be a graph. A relation is a function if each element of the domain is paired with exactly one element of the range. Yes, I would like you to write that whole sentence down. Underneath it, though, I'd like you to write the star and explain what that really does mean. In simple terms, if you can remember, for every x, there can only be one y. That is the definition of a function. For every domain x, there can only be one y, one range. When you have that down, move on to the next slide. So let's take a moment, look at a table, and look at a bunch of points, and simply answer the question, yes or no. Is it a function? Justify how you know. Take a moment and look at A. You will see a table of data. I need you to start to train your brain to see this as a set of points. This is the point -4, 0, -1, 6, 1, 5, 5, -1, and 5, 8. So take a moment just on that brief definition you've been given. Does it look like every x has only one y? The way you can help yourself answer that is when x is -4, what is its y? It's 0. When x is -1, what is its y? It's 6. And so on. When x is 1, its y is 5. Now ask yourself, when x is 5, what is the y value? That's kind of tricky because when x is 5, y can be -1 and y can be 8. So that means it fails. It is not a function because when x is 5, there is more than one y value. Take a moment and make sure you have copied down the table and you have written the sentence with the answer. It is not a function because when x equals 5, there is more than one y value. I'd like you to copy down examples B and C. This is a set of points, -2, 3, 3, 5, -1, 5, and 2, 3. It's just not arranged in a table like A. They're just listed this way. Does every x have only one y? So ask yourself, when x is -2, what is y? 3. When x is 3, y is 5. When x is -1, y is 5. Yes, the 5s did repeat, but they're in the y places. That's okay. Every one of these x's is different. -2, 3, -1, 2. They are all unique and different. Yes, it is a function because every x had only one y. Look at letter C now. Does every x have only one y? If you caught on that it's not a function, can you tell yourself which x value makes it fail? When x is -4, how many y's does it have? It could be 1 or it could be 7. So because the fact that the x repeats, -4, -4 here, that means it is not a function. Because when x is -4, the y can be a 1 or a 7. It does not pass the rule. So when I ask you, is it a function, you're simply going to say yes or no, and then tell me how you know. Justify your answer. If every x has only one y, then yes, it is a function. That's when you're looking at a table or a set of points. Let's take a moment now and look at a graph. There's a very simple, easy test called the vertical line test. So take a moment to write this down. Your next title should say, Determining a Function from Graphs. Vertical line test is simply this. Any vertical line drawn can only intersect the graph once. So here's what I'd like you to visualize. You can take a moment and draw a graph A, B, and C. Visualize a vertical line. Vertical goes up and down, just like my red line here. As I move this line across the x-axis, do I only touch the graph at one point? Because remember, every x can only have one y. So when x is right here, it only has one point it touches. However, when x is about -2, do you see that it touches the graph in more than one place? It touches the graph here and here. It has failed the vertical line test. So you would write down for A, no, it is not a function. Take that vertical line and visually picture it for example B. Does it pass the vertical line test? Well, as I move across the x-axis, I only touch the graph once, one time. No matter where I move my vertical line, it is only cutting through or intersecting that blue graph at one point. So yes, this is a function. Please make sure that you are drawing the graphs in your notes and then identifying yes or no. Look at letter C. It is a graph to look at. Is the relation a function? When I move the graph across the x-axis, do I ever touch more than one point? Right there, when x is 1, it fails. Y could be 0, or we could say this is about -2. So when x is 1, it has not one, but 2 points. So no, this is not a function. Take a moment and make sure you have all three graphs drawn and you have your answers yes and no. Now we get into domain and range. We will be writing them in interval notation. Symbols are very important and can help you with partial or full credit on your assessments. Please note that we use what I call strong brackets when we are including a certain value. You will also see them on graphs as points that are filled in. If a number is not included and it's an open dot on the graph, we use the soft parentheses. So I like to call these strong brackets and soft parentheses. If something goes on forever, we call that to infinity. Well, if you go to the right to the positive numbers, that's positive infinity. If the graph goes forever to the left or forever down, those are negatives, it would be negative infinity. Please make sure you have these symbols written in your notes so you do not forget. You will be using these symbols from now through May. All right, here's where it gets interesting. Let's look at this graph. We want to ask, what is the lowest x value? Well, as I look at this graph, it starts here, and its x value is right here. That's a -2. So its lowest value is a -2. Well, what's its highest value? Well, if I keep looking on the x-axis, this graph never ends. It keeps going to the right forever. So it never stops going to the right. So if we write this in interval notation, we are going to say this graph goes from the left, -2, all the way forever to the right. Now pay attention, that was a filled-in circle, so we're going to put a strong bracket in front of the -2, but a soft parentheses behind the infinity. We have no idea where this ends. We're not strong or definite, so we cannot use a strong bracket. Now let's look at that exact same graph and look at its range. What is the lowest y value? Well, the lowest this graph goes is right here, and its y value is a +3. What is the highest it goes? Well, it keeps going up and up and up and up and up, and it never ever ends. So that would be to infinity. So this graph goes as low as 3 and as high as forever. Strong bracket because the 3 is definite. The coordinates of this point are 2, 3. The reason that's very important for you to see, and I even color-coded them, the x coordinate of that point goes with our domain. The y coordinate goes with our range. So this point is the farthest left and the lowest it goes. So we've got a strong 3, but we've got a soft forever because we don't know how high it's ever going to end. This is a very tricky concept, so be patient with yourself. If you need to, go back, look at it again, but we're going to keep on practicing. Here's our next graph. What is the lowest? Remember, domain is x, and we look at the x-axis from left to right. So the farthest left this graph goes is right here, and its x value is -1, -2, -3, -4. So I know that graph goes as far as -4 to the left. How far to the right? What's the highest x value? Well, this graph goes as high as right here. Its x value is 1, 2, 3, 4, 5, 6, 7. So this graph goes from -4 all the way to +7. Now, this is a filled-in point, so we are going to be a strong bracket. This is an open circle, which means we get close to 7, but we're not going to include it. So make sure you use your soft parentheses. This is the point -4, +2. And this was the point 7. And then our y goes as high as 1, 2, 3, 4, 5, 6. So let's look at our range. I've kind of given you a hint with those red numbers now. What's the lowest that graph goes on the y line? It's this point. The lowest its y value will ever be is a 2. What is the highest the y value will ever be? The highest the y value will ever be is a positive 6. So can you guess what the interval notation looks like? The y's go from 2 to 6. We are sure with a solid 2, so we have a bracket, but it's kind of a soft 6 because we're not really going exactly as high as 6. So how did that one feel? Do you feel a little more confident? Do you want to go back and watch it again? When you're ready, go ahead and move on. Here's an interesting parabola that you will see second semester, but we still need to be willing to identify its domain and range. Let's look at the lowest possible x value. Well, remember, x goes from left to right. If this graph has arrows on the end, that means this graph keeps going and going and going to the left and up, and it keeps going to the right and up. So does the graph ever stop going to the left? The answer is no, it does not. It is going forever to the left, so that's negative infinity. It is going forever to the right on the x-axis, so that's a positive infinity. So you will notice with U-shaped parabolas, the interval notation is always going to be negative infinity to positive infinity. So go ahead, take a moment, get the graph down on your paper. Make sure you are writing down the correct solutions. So that one was pretty easy. Range is not too bad. Remember, that's your y line. You start as low and you go as high as you can. Well, what's the lowest this graph goes? It goes all the way down to here. That's as low as it goes. That is negative 1, 2, 3, 4, 5, 6. This is at the point 0, negative 6. So as far as the y values go, the lowest this goes is negative 6. What's the highest the graph goes? Does it ever have a stopping point? It is going forever up high. That's a positive infinity. So interval notation, the lowest this graph goes is negative 6. The highest it goes is forever. We know it's a definite solid line, so negative 6 gets a strong bracket. The infinity gets the soft parentheses. So take a moment, see how you feel with domain and range. We will be spending more than one day on this topic because this is critical to everything we're going to be doing this year. So take a moment, copy it down, and see how you're doing. Please bring your questions to class tomorrow so that your peers or I can assist you.